All right, let's talk about something that pretty much all of us deal with every single day, right inside our own homes. It's in our faucets, our coffee makers, our showers. We are diving deep into water hardness. So let's just get right into it. Have you ever pulled a glass out of the dishwasher expecting it to be sparkling clean, but instead it's covered in these cloudy white spots? Or what about that crusty white gunk that builds up on your shower head? Yeah, that stuff? Well, there's an invisible culprit behind all of it, and today we're going to expose it. Okay, so the official sciencey name for what's going on is water hardness. Now, that sounds super technical, but the idea is actually pretty simple. It all comes down to the amount of dissolved minerals in the water, specifically something called multivalent metal ions. All that really means is you've got these tiny particles with a double positive charge, which makes them incredibly good at sticking to other things, especially soap. And while there are a few different minerals that can technically make water hard, we're really just talking about two main troublemakers. The ones doing almost all the work here are calcium and magnesium. These are the two ions responsible for basically all the effects we're about to talk about. So let's break this down a little more. It's time to connect those annoying spots on your dishes to the surprisingly simple science that's happening in your water. Now, one of the first things we need to clear up is the name itself. When we say hard water, it's a little misleading, right? We're not talking about its texture. You can't feel it with your hands. It's not physically harder than soft water. It's a chemical thing, defined completely by what's dissolved inside the water, not how the water itself feels. So, how does this invisible stuff actually show up in your day-to-day life? Well, ever feel like you have to use a whole handful of shampoo just to get a decent lather? That's hard water. Those calcium and magnesium ions basically hijack your soap, turning it into this gunky residue we call soap scum. That's what stops the lather and leaves that weird film on your skin. And that limescale buildup, it's not just ugly. Get this, even a super thin layer of it inside your water heater can act like insulation, forcing it to use up to 20% more energy just to heat your water. Crazy, right? But okay, it gets just a little more interesting. Turns out, not all water hardness is the same. There's actually a really important difference between what we call temporary and permanent hardness. Let's look at these two side by side. Temporary hardness comes from bicarbonate minerals. Think of these as kind of unstable. The key thing here is that you can actually get rid of it pretty easily. Permanent hardness, on the other hand, comes from chlorides and sulfates. These guys are way more stable chemically and a whole lot more stubborn. So if you're going to remember one thing from this section, it's this. When you boil water that has temporary hardness, the heat causes a chemical reaction that makes the minerals solidify and fall out of the water. That's literally what limescale in your kettle is. But with permanent hardness, you can boil that water all day long, and those minerals aren't going anywhere. Okay, so we know what it is. We know there are different kinds. But how do we know just how hard our water is? Well, that brings us to our next section, how we actually put a number on it. It's actually pretty straightforward. Just like we measure temperature in degrees or distance in miles, we can give water hardness a specific value. The whole point of the measurement is to figure out the exact concentration of those calcium and magnesium minerals in a specific amount of water. Now, you'll probably see a few different units out there. The most common ones you'll see are milligrams per liter, or mg/L, and parts per million, ppm. For our purposes, they're pretty much the same thing. You might also run into an older unit, especially if you're looking at water softeners, called grains per gallon, or GPG. Just know that 1 GPG is about 17 ppm. But honestly, no matter the unit, the rule is always the same. The bigger the number, the harder your water is. Simple as that. All right, we've gone through the science. We've looked at the numbers. But why does any of this actually matter in the real world? Let's talk about the practical impact this has on you. And this right here is the payoff. Knowing your home's water hardness number isn't just a piece of trivia. It's genuinely useful, money-saving knowledge. It helps you protect those expensive appliances from that energy-sucking scale. It means you can use the right amount of detergent, not too much, not too little, so you save money and get cleaner clothes. And maybe most importantly, it gives you the power to decide if a water softening system is actually a worthwhile investment for your home. So the next time you see those spots on a glass, or you feel like your soap just isn't doing its job, you'll know exactly what's going on. You understand the chemistry, you know the different types, and you know how it's all measured. So the real question is, now that you speak the language of water hardness, what story is the water in your house telling you? Thanks for tuning in.